Hello everyone, my name is Michael Lucy, and I'm an engineer at RethinkDB working on the query language. And RethinkDB is a it's a new open source distributed database. It stores JSON objects like database I'm sure many of you are familiar with. But one of the things that distinguishes it that we think is really cool is that we've made our own query language for it, which is really powerful and which a lot of people seem to think is cool when we show it to them. So I'm going to talk, we ended up making the query language a domain-specific language in Ruby, as well as a few other languages. And I'm going to talk a little bit about query languages in general, and then domain-specific languages in Ruby in particular, with an emphasis on what you should watch out for, be careful with if you decide to use domain-specific languages in Ruby in your own programs, which is a good idea because they're awesome and make your code look great. All right. So I'm going to start with sort of a motivating slide, which is why did we decide to design a query language, and why did we decide to make the domain-specific language? And the short version is we decided to make a new query language because of this. And everyone can look at this and say, this is ugly. But that's not actually very useful. The question is, why is it ugly? What about this makes someone laugh? And after thinking about it for a bit, I think there are two real things that make this bad. The first one is that it has a different syntax from the language you're writing it in, which in this case happens to be a very ugly syntax, whereas Ruby syntax in general is very pretty. It doesn't follow the same conventions. For instance, select blah from blah instead of blah.select. And yeah, it's a new thing to learn, which is especially bad if you're a beginner trying to write a complicated query in it. And the second reason it's bad is because it's string-based. Now, being a string-based language has a couple of very obvious defects. You know syntax highlighting. You have to manually indent, like this guy did here because he was inside a nested block, but the language couldn't tell that because it was in a string. But there's a much more subtle problem with string-based query languages, which is that it's really, really hard to programmatically construct string-based query languages without making a mistake. And this is the root, for example, of SQL injection. The fundamental problem of SQL injection is that you have some input from a user, and you want to construct a query based on that, but you need to construct it with flat string concatenation operations. And flat operations constructing nested data structures, like this nested select statement, just never, ever, ever works out. This, incidentally, is the same reason why C macros are terrible and Lisp macros actually work. So there's one other thing that's bad about most query languages, which is completely separate from their syntax, which is that often the error messages, you can see one here, are sort of not very helpful. And I don't want to bash on SQL error messages, because on the whole, they are very, very good. They say what went wrong. They often say why. But they don't tell you the most important information for you, the programmer, which is where in my code did this error occur? They say, duplicate entry, blah, blah, blah. But they don't tell you what it's a duplicate of, or what line in your code tried to insert the duplicate, which is what you often care about. So I'm going to skip ahead a little bit now and show you what we did that we think solves many of these problems, and then talk a little bit about the challenges we encountered along the way. So this is a very simple SQL select statement. It doesn't even look ugly. Just you're selecting all the users with a number of interactions is greater than 5. And I personally think this would look better if it looked a little bit more like Ruby. So the natural question is, what would a Ruby program that does this look like? And I think it would look something like this. Basically, you have a hash table of users or something, and you want to, you have a list of hash tables, and you want to select all of them with a number of interactions is greater than 5. And since RethinkDB is a JSON object store, this is very similar to what's actually going on underneath in the database. So here's what the same query looks like in our domain-specific query language. Really, really similar. There's some name differences, but that's going to happen. But it looks right. It looks like Ruby. It's sort of pretty in the same way, and it's immediately clear what it's doing. But I do want to step back a second and say that when many people see this, they misunderstand what it does. One of the problems of looking so much like Ruby is that people apply their intuitions about Ruby to it, which can often be a problem. So despite what it looks like, this is not taking all the users on the server and then calling this block on each one to figure out which ones go into the final list. What's actually going on is that this block is called exactly once. And the way we do that is that when we call the block that one time, we pass in a bookkeeping object. And that bookkeeping object keeps track of all the operations that are done to it and builds up a sort of abstract syntax tree representing the operations that were performed. So U is this bookkeeping object. Then we invoke the braces operator on U, and U remembers it had braces called on it and returns another bookkeeping object. And that bookkeeping object has greater than applied to it. And it says, OK, so now I'm a bookkeeping object that had braces and then greater than 5 applied to me.
What is R?
It's sort of like a module. Yes?
So this is the actual language that you want to teach us? Or not?
Yes. This is exactly what it looks like. You can type this in and you have to put .run at the end, but it will return a result for you. So the R is just because we have a whole bunch of functions, and we didn't want to overload them. And it's really a module in Ruby, but we also made this for several other languages where it was much more natural to have a sort of lowercase thing and write R dot blah, blah, blah. So R is actually a shortcut function that you get by extending a module. And when you call it with no arguments, it returns a new module containing the table function. Yeah?
What about the notation of a couple of view graphs back?
Mm-hmm.
Yeah, the middle notation.
This
Can you
one.
provide that?
No, this is, well, if you write users equals r.tableUsers, then you can write exactly this, and it works perfectly fine.
There was a gem called Ambition.
Ambition?
That syntax was similar to the second one.
That's Ruby code
this one?
in the middle, right? So
Yeah.
there's
This is pure Ruby code.
and then there's the RethinkDB at the bottom.
Right.
Uh-huh.
But if you were to write users equals r.tableUsers, you could write this exact same thing with filter instead of select, and it would work.
Huh.
So the reason, once again, why we don't just define it as select is that we've implemented this query language in several different languages, and there's just no set of names that works in all of them, so we tried to pick the best we could. And filter seems to be the most common name for this operation in the sort of functional programming world, so we did that. Anyway, so we call this block once, and this bookkeeping object gets passed along and returned from the block. And then we take this bookkeeping object, which remembers all the operations done to it, and we serialize it into something like this, which is basically an abstract syntax tree of the operations. Don't bother reading it. It's really ugly. And then we send this off to the server, and the server does all the computation. So this has two major advantages. The first advantage is that if only a few users have a bunch of infractions, we aren't sending all of them over the network. We're only sending the one with the right number of infractions over the network. And the second one is for more complicated jobs, like MapReduce jobs, we can distribute the work over a cluster of servers rather than having to do it all on the client. So
this is actually though what gets executed?
This gets serialized and sent to the server, which is written in C++, which then parses it out and sort of evaluates it. But yes. Yes?
Could you say a little bit more about what exactly the bookkeeping object is?
Sure. So the bookkeeping object just remembers what was done to it and keeps track of two things. Some backtrace stuff, which I'll discuss later, and enough information to produce this abstract syntax tree here, which is the real purpose of it.
So is it fair to say that if nothing has happened to change that number of infractions, that the bookkeeping object remembers that? Is it like a cache, or does it need to go back to the database all the time?
So the bookkeeping object doesn't have any notion of a database. All it does is remember the operations performed on it. So yeah, so when it's returned from here, all we have is an object that says, first someone called braces infractions on me, then someone called greater than 5 on me. And then once we have this object, we send it to the server by calling .run on it to run the query. And the server sees this abstract syntax tree and sort of replays the operations.
So the bookkeeping object just keeps track of what it's got to do, not what
Yeah.
it has done.
Exactly. You have it.
So do you get like a cursor or something?
It depends. If you run like a MapReduce operation, which returns a single JSON object, you get it immediately. If you run an operation that gives you back like a long stream of objects, then you get back an enumerable. So yeah, basically a cursor.
Is this, so I see this is a kind of a pretty flexible approach you're taking here, but looks kind of imperative mode, like your server is answering kind of, he is answering to an imperative syntax rather than simple, which is declarative, right? So can you talk a little bit about the pros and cons between declarative and imperative?
No particular reason except that it was more similar to what people were used to. A sort of overriding theme here is that our query language should look like what people are used to writing. And there are obviously advantages to a declarative language because they can express some problems more clearly. But we felt that, especially for a new language, which didn't have any sort of history behind it, the most important thing was that it looked like what people normally wrote. And people normally write something like this, rather than declarative statements, unless they're using a logic programming language, which is sort of out of fashion these days.
The developers wouldn't be debugging with this kind of information, right?
No, and actually I will cover debugging later in the talk. We've done some really, really cool stuff with that. Actually, probably that's what I'm most proud of the query language. But before I get into that, I'd like to talk about the first thing I promised you, which is what should you watch out for when writing your own DSLs in Ruby? And the number one thing that you have to watch out for when you're writing a domain-specific language, which bites people all over the place in different languages, is something called variable capture. Now, you'll notice here, even though this variable is u, I'm actually using this random var underscore 1004 variable in the actual abstract syntax tree I generate. This is what's called a gensim in the Lisp world. And basically the idea is that while these variables are very clearly statically scoped, when you compile an abstract syntax tree of these variables, they sometimes end up in places in the abstract syntax tree where you didn't expect. So I have an example for that, which is going to be a little bit complicated, but I think you guys can follow along. So let's say we define this function getLTVal, which takes a table name, some attribute, and a value. And it gets everything out of that table with an attribute less than that val. So like the table could be people, the attribute could be age, and we could say 30, and we get all the people under 30. And then let's say we take some random table T1 and call concat_map on it. Concat_map is basically a map followed by a reduce of concatenation. So the map returns a bunch of lists, and then we concatenate them all together. So like, let's say we had a bunch of people, and one attribute of these people was their parents. If we called people.concat_map and we selected their parents, it gives us back a list of all the parents of everybody by concatenating the lists of parents. But the actual function is not important. What's important is that it takes a variable x in its block, and then then it selects an attribute from that object and passes it to getLTVal. But because this isn't evaluated immediately, but is instead compiled into an abstract syntax tree, what actually happens is that it turns into this real ugly thing. So there are two variables here, var 1006 and var 1007. var 1006 is this x, and var 1007 is this x. And the reason we have to give every single one of these variables a unique name is that if these were instead called x, this reference to var 1006 would actually refer to var 1007. Like if we replaced all these strings with x, this would be bound by this binding rather than the binding we intended. And the reason for that is that when we look at the code here, we only see this x, but this doesn't actually evaluate something. This doesn't evaluate like a variable and pass it through. Instead, this sort of expands like a macro expansion into another expression. And this x ends up inside that expression where a new x has been introduced into scope. And we say that the new x has captured the variable x, and now it is bound to the wrong value. When I talk to people about this, this is often the most confusing thing. So if you have questions about it, please feel free to ask me after the talk. I would love to go into it more. But in the meantime, let's move on to the second biggest problem we've run into, which is that infix operator overloading in Ruby kind of sucks. And there are like a few different reasons for that. which I'm going to go into now. The first one of which is that infix operators in Ruby are only overloaded by the type of their left-hand side. So if you write something like this, what happens is this calls the bookkeeping objects greater than function on 5. But if you write something like this, Ruby tries to do its fixnum less than, and tries to coerce the bookkeeping object to a fixnum, which of course it can't do. So in other languages like Python, you have infix operators that are generic on both of their arguments, and this isn't a problem. But in Ruby, this works fine, and this throws a terrible, terrible error. So what can we do about this? What we eventually decided is that we would take R, which was already our module, and allow for it to wrap values like this. So here, R of 5 turns 5 into a bookkeeping object that just remembers the value 5. And this still looks pretty, which is fundamentally what we're going for. Or he doesn't think it looks pretty, but I think it looks prettier than the alternative. I mean, clearly this is the best. You should write this if you can. And yeah, honestly, we're sort of unhappy with this. But I would recommend if you're making a DSL of your own and you can, by any stretch of the imagination, avoid infix operator overloading, please try to do it, because it does not work out well. Another problem we've had with infix operators is that some of them you just can't overload. So not allowing you to overload and like Boolean and or seems pretty reasonable, because you can't, with a function, implement short-circuiting behavior like you'd expect the operators to have. But not allowing you to overload these two has actually caused us no end of trouble. Because the way this works in Ruby is that equals not is actually defined as the Boolean not of whatever equals equals evaluates to. So if we overload equals equals on our bookkeeping objects, and someone writes equals not, what happens is it runs the equals equals, gets back another bookkeeping object, and then takes the Boolean not of that bookkeeping object and returns false, which is completely useless to us because it doesn't keep track of what happened. So we just gave up on this. Like, there was nothing we could really do about it. But for these, we did something which is sort of like wrapping the R in a 5. I think it's better than the alternative. We're still not very happy with it, which is we decided to overload and or by overloading their bitwise equivalents. I override bitwise and bitwise or. Like, this is bitwise and here. But this has a new problem all of its own, which is that the precedence of bitwise and is completely different from the precedence of Boolean and. And in particular, it binds more tightly than comparison. So if you write A less than B and C less than D, this is how it binds. You're checking that A is less than B and C is less than D. But if you write A less than B bitwise and C less than D, it thinks of this as a mathematical operation. So it binds like this instead, which is obviously incorrect. So originally, we were doing something very, very cool, where we kept track whenever you called an inline bitwise and or operator, and we took the resulting abstract syntax tree, and we rejiggered it to have this precedence instead, which was really, really cool and very intuitive for people, because people don't even think about this. They just write the single ampersand where they would normally write 2. But then this had a whole new set of problems, because if B happened to be a number, then you were back in the problem of only overloading on the left-hand side. So something that was otherwise correct once you added this ampersand would suddenly become incorrect, because we couldn't rejigger the abstract syntax tree without generating it, and we couldn't generate it because it was still trying to coerce C to a fixed num. So what we do instead is we just detect the case where people have written something like this, i.e. where they're doing a comparison on two things that were bitwise anded or ored together, and we return an error to them. And this sort of segues into what you were asking about, I forget who, earlier about errors, which is that probably our overriding principle about errors is that we should try an error early, and we should try an error if it's really likely you're doing something wrong. You might conceivably want to be comparing two Booleans here, but you probably don't. So if you write something like this, this is the error we get back to you. I apologize if it's hard to read. We say, cannot use the infix less than operator on infix Boolean expression, all of 2 and 4. This is almost always a precedence error. Try adding parentheses, blah, 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 blah. If you really need to do this, you can use the prefix operator, etc. Which sort of segues into the more general question of error reporting, which, as someone alluded to earlier, is really difficult in DSLs. And the reason error reporting is really difficult in DSLs is that DSLs add an extra layer between what the user types and what error actually occurs. The distance between the text the user has actually entered and the text they see on the error message is usually very large. So they see, this internal thing in my DSL, or even worse, this internal thing on the server failed because these two values weren't the same. And it's completely, completely useless to them. But we've done some really, really cool stuff with error reporting to make the DSLs not be so bad. So, to set it up real quick, this is the error situation we're going to look at the error message for. We have this table of people, and we're going to insert a couple of people into the table. Each person has a name and some points. So Alice and Bob are valid people, but we also have a person, Mallory, whose object is malformed because it doesn't have a points attribute. So then we map over the table, the same as Ruby map, and select the number of points. And then we reduce over that and add it all up. So if Mallory were not malformed, this would return the total number of points in the table. But Mallory is malformed. So what's going to happen here? We get back this error. The first notable thing about this error is that it tells us what object in the database had it. If you remember the SQL error from earlier, it said there was a conflict, but not what object it was conflicting with. We show user the actual object in the database that the error occurred on. And then the second thing we do, which is really, really cool, is we tell people what line of their program the erroneous portion of the query was constructed on. And I want you to think about that for a second, because it's not what you immediately think. We don't show them the line the query was run on, which you can get out of the backtrace, and is line 5. We don't even show them the line of their program where the entire query was constructed. We show them the line of the program where the portion of the query, in this case ages, that had the erroneous code was constructed. And the way we do that is that there's a really cool function in Ruby called caller, which gives you a backtrace at the current location in the code. So every time we construct one of these bookkeeping objects, another thing we keep track of is where in the code it was constructed. And then later, when we get an error from the server, we can show people what line of code they constructed the erroneous portion of the query on, which I think is just really cool. Yes?
Yeah, I'm familiar with caller. In fact, I was looking at it today. How do you know in the backtrace, wouldn't it happen at different lines? Is it line number 2, 3, 4? Or
so this is
which place is the one that caused the error?
This is something we thought about. So, oh, I'm sorry.
It gives you a list of, it's like the backtrace, right?
Yeah.
It's a way to think of it. And it goes backwards. It shows you, where exactly that line 4 in this program. But the question is, which of those lines? I did one today, there were 78 lines.
Yeah. So the basic question is, we have this long backtrace with a whole bunch of lines in our program, and we need to figure out which one is useful to people. So this is something I actually argued about with myself a lot. And what I found is that on the queries I happen to write, which might not be everybody's, the very last line before we entered ReQL code was often the most useful. So basically, we look at the backtrace, we keep going up until we get out of library code that we wrote and show people that line. But we also had an earlier version of the product which instead showed people the entire backtrace. And we decided not to do that because, as you noted, sometimes it's 80 lines long and destroys the succinctity of the error message. That's not a word, is it? But we found in practice that showing people the last line was very useful. If it turns out that with the queries people are actually writing, they complain that it isn't, we might do something smarter or provide an option to show the whole backtrace or something like that.
Yeah.
Yes?
Can you talk a little bit about the typing? Like, do you support any typing? Like, I'm thinking, for example, if you enforce some kind of types at the beginning and you pointed out to them that malware is malformed because of type validation, you probably didn't have to go through all of this, like, discovering, right?
We thought a little bit about, well, so we do some type checking, but it's very minimal because we don't have an entire JSON parser. So like, if you have an object like that's clearly a stream, you can't try and add 5 to it or something like that, because we can detect that. But we basically don't enforce any sort of schema on our database. And we do that for the simple reason that for the particular people we're trying to sell to, schemas are sort of annoying because they slow down development. If you really want safety, you should probably use a full-blown relational database that has a schema and can enforce it for you. But we don't do that.
How do you convert the date time to a database-specific thing from Ruby to?
The date time?
Yeah, like different data types. In this case, you have only integer and string.
So basically, yeah, sorry. So he asked how we convert the Ruby data types to data types that we can store in our database. And the answer is that the insides of our database are all based on JSON. So we just import the JSON library, and any Ruby data type that can be turned into JSON, we just turn into JSON and send to the server. And if you have your own data type that you want to be able to serialize into our database, and you define it as something that can be turned into JSON, we'll turn it into JSON too and store it. A JSON object, I mean. Like, we won't store a JSON array for you. So, any other questions about this? All right. So here's the second thing we do that is really cool, which is that on the server, we keep track of where in the execution of the query we are. And when we throw an error back to the client, we send back to the client a backtrace of like where in the query we are when the error occurred. And in this particular case, the backtrace shows that the error occurred while trying to get the attribute points out of this variable, which unfortunately is not named x because of the variable capture problem we discussed earlier. So I think this is really, really cool. Both the fact that the complicated bookkeeping object we construct can be printed out as a reasonable string representation of the query you ran, and the fact that we can serialize a backtrace from the server and show you, like, with underlining, what code did you write that broke, and what line was it on, really, really helps when people write some obscure query that gets compiled to an even more complicated object and run on our server, and they want to know where it broke. All right. So to basically summarize the 3 things I've said about DSLs, the most important thing, if you're writing your own DSL and you haven't done a lot of it before, is to watch out for the problem of variable capture, because it bites a lot of people who are new to doing DSLs. My second piece of advice would be that if you're doing one in Ruby and it's not absolutely vital that you overload an infix operator, I wouldn't try and do it. I would just save yourself the pain. And the third one is that when you're doing error reporting or you're defining how to inspect an object, you should try as hard as you can to show people what they typed, rather than your DSL's internal representation of what they typed. Or even worse, what happened on a server somewhere else with its internal representation in a different language of what they typed. Because people don't care so much about what went wrong, they care about why their code is wrong, what line they have to change. And then a little more abstractly on the topic of query languages, the first thing I would say is that if you ever find yourself writing a query language, DSLs are great. Like, when we show this to people and they actually sit down and play with it, they seem to love it. And anecdotally, myself using it, it really is fantastic. Second thing I would say is that if you can mimic the host language, that is really good, because people already know what it's supposed to look like. They already have all these code smells in their head. And the host language was probably designed reasonably well. I mean, it's probably going to be fairly readable. And the third thing I would say, which ties into the DSL error reporting earlier, is that you should try as hard as you can to report where errors occurred in their code. Not what went wrong on the server, but where it went wrong, both in their code and in the database. Like, what object had the conflict, and what line in your program did it conflict with. So that's my talk. We have not released yet, but are going to in a very few number of days. You can go to RethinkDB.com to sign up to get informed when we actually do release. Or if you want, since we're open source, you can just pull the code right now and start playing around. And you can install the driver straight out of gem. The driver you install out of gem should be very close to what I described here. It might be a few days behind just because of how our release process goes. But if you wait a few days, it'll be what I described here. All right. Any questions? Yeah.
I think it was very interesting what you mentioned. But how about the infix operator? Like, I would suspect that if you don't have these infix operators, I think your DSL would not be as expressive. So can you share where do you draw the line between expressivity and how you work around that?
So we were basically stuck with infix operators, we felt like, because in queries, people very frequently wanted to express fairly complicated arithmetic expressions. Like, this plus this is less than that divided by that modulo 4, or something like that. So for the particular case of DSLs where there's a query language, I think there's no getting around it. You have to have infix operators, or else you have people using prefix math, which no one except Lisp programmers is willing to put up with. But if you're writing a language that is less heavily dependent on complicated numeric operations, I would avoid it. So that's where I draw the line. But, obviously you should use your own judgment. Yes?
I guess too. So lots of what do you call it, NoSQL DBs out there. Where does this fit in the landscape? What niche are you trying to scratch?
So his question was, where do we fit in the landscape of NoSQL databases? Basically, we want to fit in the landscape of people running 1 to 15 servers who want clustering and some stability, who are not as concerned about speed as some other people, but still want it to be fast, and who want to be able to run powerful queries. If you don't need to run anything powerful, if you don't need to run MapReduce jobs, there might be a better solution. Or if you need safety, if you need a schema enforcement like someone was asking about earlier, probably a full-blown relational database is what you want. But I think we fill the niche of people who want to run a smallish but not incredibly small NoSQL database and want to be able to do powerful operations on the data really well.
A lot of the other ones use JavaScript, right? Like Mongo, Couch.
So
why was your choice to go native with other languages? Was it for the queries?
So
you were writing wrappers.
So we do also allow people to provide, he basically asked why we didn't just use JavaScript instead of doing all these wrappers in the languages. And we do allow people to provide JavaScript. You can provide a chunk of JavaScript, it'll run it on the object, and we will, do that. The reason we also provide all this other stuff is that often the JavaScript is slow. It introduces an extra dependency because the way we do it is we integrate with V8. And basically, if you trust V8, that's fine, but not everyone does. And the third reason is that it's very hard if you have a chunk of JavaScript to prove that it deterministically evaluates to the same thing if you run it twice. Which means that, especially if you want any sort of speed, you have to run all these chunks of JavaScript in the same V8 engine. And because of the way our database is structured, if you have a query that can't be proved deterministic, we have to do a less efficient operation to send it out to the replicas, because we can't have 2 different replicas running it twice and getting different results. That will just absolutely destroy everything. So basically, JavaScript has performance problems, is the short answer.
But if you raise the bar at the probability and stuff like that, I don't think too many languages should be able to jump over that. Even Ruby, for example, could be debatable if we can prove it or not.
Right, but so the question was basically, most languages can't be proved deterministic. And that's true, but we allow a very small subset of Ruby. We don't allow people to provide Ruby programs and run them in a Ruby interpreter. We just wrote a DSL that looks like Ruby that compiles to a language we know is deterministic. Or as much as you know anything. But
Is it fair to say that doing this in Ruby is going to look a little more expressive than, say, trying to do it in JavaScript?
He asked whether it was fair to say that doing this in Ruby was more expressive than doing it in JavaScript. And I think the answer is yes, because we also have a JavaScript driver. And in my opinion, the Ruby driver is much better.
Yeah, I mean from the client's point of view. From my point of view, writing the query.
follow up on that question. So what was the driving decision? Was the expressivity of the host language, or it was the market for your DSL? So deciding to go for the Ruby syntax.
So the question was, what was the driving decision for going with Ruby syntax?
For the DSL.
For the DSL. And the answer is basically a lot of people wanted to use Ruby, so we're going to do something in Ruby. And we figured if we're doing it in Ruby, we think a DSL is better than strings, and we think a DSL that looks like Ruby is the best DSL there could be. Any other questions?
See the string you send it to the server. What does it do before it sends out to the database? Does it do any other conversion?
So the question was basically what happens when all this stuff gets sent to the server. So we start with an abstract syntax tree that looks something like this. And the very first thing we do is we serialize this to a protobuf, which, if you're not familiar with it, a protobuf is basically this format from Google that has very good forward and backward compatibility properties, which means that we can later update the language without breaking all the older clients. And we send this protobuf to a particular node in the cluster. That node in the cluster then deserializes the protobuf and gets back something that looks very similar to this on the other end. And it takes that and resolves the table, or the shards of the table if it's sharded, where all the data you're trying to access lies, and sort of sends out the appropriate portions of the query to those parts, to those nodes in the cluster. And then those nodes compute what they have to do. They store some data if you're doing a write, or return some data if you're doing a read. If you're doing a computation, the computation is distributed over those nodes. Like if you're doing a map reduce, it does the mapping and reducing per shard on each shard. And when it reads the data out of the database, it just gets a JSON string and turns it into an internal JSON object and does all your JSON operations on it, and turns it back into a string to send back to you. And then the Ruby JSON library deserializes it from the string into a Ruby hash or a Ruby array or something like that, and gives it back to you as a Ruby object for you to do whatever you like with.
Talking about the strings, you said that the SQL is not good because it's having too many strings and stuff. How did you solve that problem with the DSL? I haven't seen it.
So no, the problem is not so much that SQL has too many strings, it's that it is a string. So this is just one giant string, which means if you're constructing it programmatically, you're doing it with flat operations. Whereas this is a block, which is a fundamentally structured object. There's nothing people can put in the block, no special character that they can put in the arguments they give you that will allow control to break out of that block and do something else the way you can with SQL injection. And also, because it looks so much like Ruby syntax, Ruby will highlight it correctly. Whereas if you have a long SQL query in a string, it isn't highlighted correctly, it isn't nested correctly. You saw that guy was manually indenting a few spaces to show that he was inside of a nested query. Yeah.
Besides just showing the line number, is there any tool support for debugging my queries? Just the string, I can't really debug my nested huge query, inner joins or whatever. But this one you just showed us a very simple example. If I'm writing a very complicated query, how would I go about, where exactly it's having a problem?
Didn't you show that you are underlining, where in the query?
So there are sort of two answers to the question. Was basically, if you have a more complicated query, how do you figure out what's wrong with it? So the first answer is that we try our absolute best to underline the relevant portion of the query for you. And we basically always can. But sometimes just knowing the portion of the query that broke doesn't tell you semantically why it broke. And the really cool thing about us looking so much like Ruby syntax is that you can often debug your query by just breaking it into smaller queries and running them, and then running the other operations with the Ruby function names interposed. So for example here, the ages table, this map is a map that's occurring on our server. If you don't quite understand why this map isn't working, you can just put a .run here instead and get back a long list. And then you can map over it in Ruby and see what happens in Ruby where you have all the tools you're used to. Now, that isn't always perfect because we enforce some stronger safety constraints than Ruby does. Like, Ruby will not error if you access something in a hash that doesn't exist. It'll just give you nil. Whereas we throw an error because almost always if you're doing a query and looking for an attribute that doesn't exist, you want to know right away. You don't want it to silently turn into a nil on you.
So do you have your own console, or is it just IRB? You could just go in and play
IRB.
IRB.
The question was whether we have our own console or whether you just use IRB and go in and play. And the answer is IRB. We also, on the administration page for the cluster, which is a web-based interface, have a data explorer that lets you do the same thing in JavaScript if you happen to be somewhere that doesn't have Ruby installed and you really need to fix a problem. Yes?
Can you talk a little bit about what did you use to implement this, like what libraries and underneath and stuff like that?
So the only two external libraries we depend on are JSON and a protobuf library for serializing and deserializing the protobufs. Internally, the way this is implemented is basically just an object with all the functions we care about overloaded on it, and then a bunch of really nasty bookkeeping logic to make sure it all sort of fits together. There's very little fancy software engineering under all of this. There is some on the server to return the backtraces correctly and stuff even over the network, but yeah.
No parser, nothing?
No parser? No parser of any kind. We use the parser in the JSON library to turn JSON into Ruby and vice versa. But since we aren't dealing with string languages, we don't really need to deal with parsing structured data out of unstructured text.
Ruby has tools for creating an abstract syntax tree, right? So why did you decide to write your own abstraction, creating this abstract syntax tree versus using existing tools?
So that's sort of a funny story. The question was why we decided to do our own abstract syntax tree thing instead of just writing our own tools, instead of just using some existing Ruby abstract syntax tree stuff. And the answer is basically that when I first started writing the Ruby driver, I wrote this really clever thing that used method missing so that I didn't have to write a lot of code I would otherwise have had to write. And the method missing just concatenated things into arrays and did some cleverness and then tweaked it into a protobuf at the end. But then we got around to actually documenting the thing. And it turned out that we wanted to use RDoc, obviously. And we couldn't just put a giant RDoc comment above method missing saying, this does these 20 functions. So I had to go back and undo all of that. But in the intermediate period, we had written a fuzzer that used this abstract syntax tree thing we constructed and recombinated them to generate new queries to sort of bang on the server for us. So it already depended on this internal representation, and we couldn't rip it out entirely. So we are now, unless we want to rewrite the fuzzer, which seems unnecessary, sort of stuck with this. But it's not that bad.
Shouldn't be the method missing the last option
Yeah.
instead of being the first option?
So I also, full disclosure here, I had not written that much Ruby before I started writing this client. And so I had a couple of notions that were beaten out of me very quickly. The original question was, why in the world did I use method missing? And the answer was that I was young and naive.
Did you
The
write
first
the
thing
other,
you use.
Did you write the ones for Python?
I got to use this.
So the question was whether I also wrote the Python and JavaScript drivers. And I did a small amount of work on the Python driver, but in general, no. I've only done the Ruby driver.
What language would you use, which you think would be more appropriate to write this DSL thing better?
I honestly don't know, because on the one hand, operator overloading is not as bad in Python. The question was what language I would pick if I were doing this and only had to do one language. But on the other hand, Python, instead of being able to use these blocks, we have to use Lambda functions, which look much uglier and can't do much work inside of them since they can only contain an expression and not a statement. And just generally, the Ruby code looks much prettier than the Python code when I look at them side by side. If I had my choice of any language, I would pick a Lisp and do this in macros and have it all work right. But if I were picking a language that I expected we could actually sell people to, I would probably pick Ruby, actually, despite the operator overloading problems.
Yeah, your syntax tree looks, to my eyes, very Lisp-ish.
Yeah.
Yeah.
Definitely an influence in the design of it.
Good thing is developers don't have to worry about that.
Yeah. Hopefully people will never actually see that abstract syntax tree representation. The only time they ever do is if we missed some error checking somewhere in the client and things only fail during protobuf compilation, in which case like we do a nasty dump of that. But in theory that will never happen, by which I mean it will at some point.
Yeah. And you'll get an email from us.
Yeah.
What is this?
Can you talk a little bit how does this compare with like a Mongo and other similar type of things?
You mean the query language or the
If you
database?
write a chart and take
Mhm.
some factors, you know,
The database
where
is
would you fit? Where would you go in the graph? You know,
Mm-hmm.
it would be a nice graph for us to get a graphical
Mhm.
view of how you fit in the landscape. You know?
Joey, do you want to comment on this?
I didn't hear the full question.
The question was basically where do we fit in the landscape of other NoSQL solutions?
So we're definitely the closest NoSQL solution to us is Mongo. Both of us have kind of designed a much more advanced query language, right? We're not a key value store. We offer a much greater variety of queries that you can go for. One of the things that wasn't covered here, but we've talked about in the past, is the fact that we offer joins, and you actually do a distributed join throughout your cluster. And we actually have like a whole talk that we didn't go into tonight, but we could always, if you guys are interested, tell you guys a little bit about how we do that. But Mongo is definitely by far the closest thing to us, and similar kind of installation size. Michael mentioned earlier about up to like 15 machines. Nodes makes the most sense, and that tends to be very similar to what Mongo does.
So the sort of short version of that, just for the sake of the camera, is that we're a lot like Mongo, but we do joins, we aren't a key value store, and we're targeted at about 15 machine clusters right now. Yeah.
And for the DSL, so in general, a DSL is for a specific type of problem, but from what I understand, you are kind of defining a general database here. So I'm not sure then how does the DSL work? What specifically, what would be the keywords, and how do you design that DSL?
So the question was basically, hey, how is this a DSL? How do we design it since it's so general? And in my mind, the specific domain we're covering is querying a database. So that drives all of our design decisions. It drove our decision to use the infix operators despite the pain, because when you're querying a database, you need to do complicated arithmetic comparisons. It drove the selection of functions we include in the DSL. Filter, map, reduce, things you actually want to do to a database. And it drove our block syntax because it turns out the process of querying a database can often look very similar to the process of manipulating lists of objects in Ruby, which people are very familiar with.
What do you think of Mongo's idea? They're going to add SQL syntax to their drivers.
I have absolutely no opinion, I'm sorry. The question was how I felt about Mongo and SQL, and yeah. Yeah. All right. Yeah?
Are you guys a good option for graph style data?
The question is whether we're a good option for graph style data. I don't think so.
No,
Do you-
like Mongo, you can take JSON and put it in the document, and or you can embed. They focus on document-related issues, right?
Yeah. Well, so we store JSON documents too. Like our JSON objects can contain other JSON objects, and it goes all the way down. But we aren't like specifically targeted at graph databases.
I think that complex as they are right now, right?
Yeah, there are other people that focus more specifically on that,
Mhm.
if that's
Sure.
your main interest.
Mhm. All right. Thank you all for coming.
Thank you.